Greetings everyone, and welcome back to our channel. Today we're shifting gears. No unboxing, no benchmarks. Well, perhaps a bit. We're delving into the core of every application, every website, every piece of software you've ever interacted with. Code. Specifically, how that code transforms into a functional product, which is far more fascinating than it might initially seem. Trust me. Consider this. You have a recipe, which represents your code, but how do you convert that into a delectable dish, a functioning program? This is where compilation and interpretation come into play. Let's dissect it. Picture yourself as a master chef. You have an exceptional new recipe to experiment with. You meticulously read and memorize the entire recipe. You understand every step before even lighting the stove. This process is akin to compilation. Compilation translates your code into machine code. The outcome is an executable file, ready for execution. Your computer has the entire plan pre-arranged. Compiled languages are renowned for their performance. However, modifications can be cumbersome. Now let's switch gears. Imagine a different kind of chef, one who thrives on spontaneity. This chef grabs their recipe and starts cooking right away, reading and executing each instruction one by one. They chop an onion, then read what's next. Maybe grab some garlic, read again, and so on. That's interpretation in a nutshell. In programming, interpreted languages like Python, JavaScript, and Ruby work this way. The code is read and executed line by line by a program called an interpreter, which acts like that chef following the recipe in real time. This cook-as-you-go approach has its advantages. It's flexible. Want to change an ingredient? No need to retranslate the whole recipe. Just tweak the line of code, and you're good to go. It's like tasting the sauce and adding a pinch of salt on the fly. This makes interpreted languages awesome for rapid prototyping and web development, where things change quickly. But remember, there are always trade-offs. Because the interpreter is reading and translating on the fly, it takes a little longer to execute the code. It's like our chef pausing after every step to check the recipe again. This can affect performance, especially for larger, more complex applications. Okay, so we've got our super prepared chef and our freestyle chef. But what if there was a way to combine the best of both worlds? Enter the hybrid chef. JIT compilation. This chef takes a look at the recipe, identifies the parts that are used frequently, and memorizes those sections. The rest? They'll refer to the recipe as they go. It's like memorizing the steps for making the perfect roux, while still checking the recipe for the specific spice blend. JIT compilation, used in languages like Java and C#, does something similar. It compiles parts of the code into machine language on the fly, prioritizing frequently used sections. This means you get some of the speed advantages of compilation, while retaining the flexibility of interpretation. It's like having a cache of pre-prepped ingredients ready to go, while still being able to adjust the recipe as needed. This hybrid approach is a great balance for applications that need to be both fast and adaptable. So, there you have it. Compilation, interpretation, and JIT compilation. 3 different approaches to transforming code into something you can actually use. It's like choosing your chef style in the kitchen of code. Do you prefer the raw speed and efficiency of the master chef, the flexibility and rapid iteration of the freestyle chef, or the balanced approach of the hybrid chef? Each approach has its strengths and weaknesses, making them suitable for different scenarios. The best choice ultimately depends on your project's specific needs.